Alright, hello everyone. My name is Sion Pinjur along with my partner Triomo. So we are going to talk about the topic that is special machine, under which we are going to discuss more on stepper motor. For this topic, our outline will be introduction, working principle, which I will be dealing, and application conclusion. So with this, we move on the introduction part, which will be dealt by my partner Triomo.
So, a stepper motor is an electromechanical device which converts the electrical power into the mechanical power. So, we can also define it as a special electrical machine which rotates in a discrete angular step sign response to a programmed sequence of input electrical pulses. It is a brushless synchronous electric motor that can divide a full rotation into an expansive number of steps. A standard motor will have step angle of 1.8 degrees with 200 steps per revolution. It is also similar to a switch reluctance motors. The stepper motor uses the theory of operation for magnets to make the motor shaft turn a precise distance when a pulse of electricity is provided. So this is the diagram of a stepper motor. Here, these are the types of stepper motors which we can see throughout the world, and this is the main internal construction of a stepper motor, where we can see the rotor section, magnet, rotor section, rear end cap, stator, winding, bearing, shaft, front end cap, which will be further explained in the later videos.
Once again, hello back. So as we move through the topic stepper motor, so we already seen the interior part of it. Now we are going to discuss how this motor actually works. So that's right. So we are going to talk about the working principle. So now a stepper motor, like any other motor, it uses the magnetic field to control the movement of a stator. But in this situation, the stator does not rotate like that of a normal motor, but instead it takes a step-by-step movement. So a stepper motor, the stepper motor in the diagram given here, we can see it has the two parts, that is the still part, which is the stator, and the moving part, which is the rotor. The rotor can be either in permanent magnet or an iron core that can change how it conducts the electricity. So we simply need the behavior that can conduct the electricity for this. So the stepper motor moves in a small and precise step, as I mentioned earlier, by controlling the electricity in the coils on the stator. In this figure 1, if we look it carefully, we already know that we can see here this rotor, the stator, and also the stator winding. So a stepper motor works like this. Now when you turn on one or more of its coil faces in the stator, as we can see here, we have the six stator: A positive, B negative, C positive, A negative, B positive, and C negative. So these are the stator, and when you turn on one of the coils face in the stator, it creates a magnetic field. Now the rotor, which is the moving part, this rotor, it aligns to this stator when the stator is turned on, as and when this stator creates a magnetic field. To make the rotor turn, we need to activate driven phases one after the other in a specific order. Now it simply means that we need to on the stator order by order in order to make the rotor rotate in a stepwise. For instance, we are activating here A. The rotor we see here gets aligned to the A positive stator. Now once we deactivate this A and activate this B stator, the rotor will rotate in a 60-degree, aligning to the B stator, as we can see in this second figure. And again we deactivate this stator B and we activate this C. The rotor will again rotate it and align it 60-degree again to the stator, as we can see here C. That way the rotor in the stepper motor, we get to see it moves step by step. So this makes the rotor move by a certain amount, bringing it to the desired final position. For the further explain, let me just point it here. In figure 2, in this figure, we can see how this works. At the start, coil A is turned on. This coil A is turned on, and the rotor lines up with its magnetic field. Then when coil B is powered, When this coil B is powered, the rotor moves 60 degrees clockwise to align with the new magnetic field. The same thing happens for this C. When C is activated, the color of the stator teeth in this picture, the blue color, shows the direction of the magnetic field that they create.
Now to talk about the applications, stepper motor have lots of application in a real world. The stepper motor is used for precise positioning with a motor like hard disk drives, robotics, telescopes, and some toys. It is also used in industrial machines as automotive gauge and machine tooling, automated production equipment. It can be also used in security, new surveillance products for the security industry. Medical stepper motors are used inside medical scanner, sample, and also found inside digital dental photography. So they can be also used in DSLR cameras, ATM machines, engraving machines, video cameras. Now to come to a conclusion, stepper motors offer cost-effective and precise motion control. They work on the principle of electromagnetism, so they are widely used in robotics, industrial machinery, security, and healthcare in medical. Now some of the advantages of the stepper motor are it has high torque at startup and simplicity as construction is simple, and disadvantages potential step loss under heavy loads, lower efficiency when idle. So they play a crucial role in achieving precision and control in various applications. Thank you.